Hello and welcome along to my presentation on how we can use GIS apps to explore the mantle. Now, it wouldn't be a GI conference if I didn't talk a little bit about the plates and plate motion and, of course, the zombie ideas of convection currents that are so prevalent in many of our textbooks that really need to be slayed, because the modern understanding of how plates move is much more related to the process of slab pull. This is the cold, old, dense lithospheric plate sinking into the mantle, and as it does so, it pulls the rest of the plate with it, kind of like a chain dangling off the edge of a table will pull the rest of it with us. And yet there are misconceptions about that type of plate margin, that destructive plate margin, everywhere. And I want to explore just one of them here, because the question is, at a destructive plate margin, what exactly is being destroyed? You get diagrams like this, which will show the descending plate melting down into the mantle. And it kind of intuitively makes sense, because if the crust is created at a constructive plate margin, it must be destroyed at a destructive plate margin. Yeah, right? Wait, what? Well, hold on a minute. If we've just established that the main driver of plate motion is the cold sinking slab, and then if we melt that cold sinking slab, what exactly is pulling the plates? And that is where we come into this wonderful world of seismic tomography. That's how we see what's happening within the mantle. Congratulations, it's a descending slab of oceanic lithosphere. Seismic tomography is kind of like a CT scan for the Earth, and it works like this. You'll have an earthquake happening. It will send out shockwaves. And as those shockwaves travel out, they will arrive on time at a particular location. Then you will have a particular area where they seem to get a Super Mario Kart speed boost, which means they'll arrive early at a location before these waves will arrive on time. And that allows us to infer something of what must be happening here within the mantle. And it's inferred that that represents a cold old descending slab, because basically the material of the slab being colder and denser will allow the seismic waves to travel through faster and will allow them to arrive early. And that allows us then to explore what's happening in the mantle through seismic tomography to see what's going on down there. And I want to demo for you one of the apps that we can use that will allow us to explore just that. And welcome along to Tic-Toe Globe 3D. And this is a pretty intuitive app that allows you to take these field trips into the mantle itself. So let's take a wee look. The first thing we've got to do is to get it to display some data. So we come down here for seismic tomography, and I'm going to pick the seismic tomography model. I also like it to display some of the hypocenters, which is the American term for earthquake focuses. And we can see that they're all appearing here. It's a simple matter then of coming up to actions, and we want to draw a cross section. I'm going to tap here, I'm going to tap here, and lo and behold, look at what appears over at the side. We have this model here of the slab descending into the mantle, and we can see the slab marked by the cooler, bluer parts of the seismic tomographic viewer. And if I can drag this around, we can see that we can set the different depths to that, and we can go and take a look at, let's go extend to cover the entire globe. That shows you our little section here in the context of the entire globe. And of course, we can turn this into 3D, allowing us to explore in 3 dimensions that descending slab going down into the asthenosphere. The cool thing now is that because we've explored one of these, we can come and explore a few of them together. So let's come over here now to Japan, and we'll cover this little bit of the area. So I'm going to deselect the 3D here. I'm going to click, and here is a new display of this particular area here. It allows us then to do an interesting comparison with, say, that area of Japan and this area here. We've got the Mariana Trench, the deepest trench in the world, has much, much steeper subduction. Look at the subduction going down here, and the bending of the plate makes the trench much, much deeper than you would get here. This can be used as a simple teach from the front tool, or if you've got access to the computers for your classes, they can go and explore these and take field trips to the mantle thanks to this lovely little app.